Hello, this is Neapolis. Please, let's take our pen, our notes, and our calculator whilst watching. Whilst we are watching, let's jot something down. Don't just watch. This is not a movie. So let's start. Our topic for today, indices and logarithms under core mathematics. These are our objectives for today. We are going to solve for um, equation under the logarithm. So solve for the following equation. Okay. Now, solving for this kind of equation sometimes is very difficult. It's impossible. So we have to what? Involve logarithm idea under this indices equation. Okay. Indices equation. Good. So 2s equals 5. 2s equals, because 5 cannot be break down maybe to the power nothing will give us 5. It's impossible. So therefore, we have to apply the idea of what? Logarithm. That's what I'm saying, that indices and logarithm, they work together. They work together. So let's take log on both sides. So after taking log on both sides, then you can solve for this. So take log 10 on both sides, or yeah. So you take log 10 on both sides. Good. And now this has become the power rule. That's all. The story building. So you have to reduce this story building. That's what we call log about sign. Okay. So the s will be here. Then things will be much easier. We are solving for s, right? So we just divide both sides by s, so that this one will cancel. Divide both sides by s. Divide both sides by log 2 to the base 10, rather. Sorry. Divide both sides by log 2 to the base 10. Then divide here to by log 2 to the base 10. Okay, so this and this will cancel. Then left with this. So this is what we are saying. Yeah, this is what we are trying to say. Yeah, so therefore our s is equal to this. So from here, we can just, so we say we should solve. So this is not just simplification. Simplification, just leave the answer like this. So we should solve. So use your calculator. Log 5 to the base 10 and log 2 to the base 10 will give you this using your calculator. Therefore, our s is this. Very simple. Very simple. Very simple. Very simple. We have another one here. We should solve this one. Let's solve this equation. This indices equation. We solve this under indices. So let's solve this here. Under indices equation, the time we're solving this, let's expand it. So this 3 to the power 2s can be written as 3 to the power s2. The same thing. Then from here, negative 3 to the power s plus 1. And indices, we have what? The product rule. Okay. So this can be written as well. 3s times what? 3 to the power s times 3. This is what can be written as this. Under indices, we have the product rule. Good. Then plus this. So now we let A represent 3s. We have solved this question under indices. So we are just revising ourselves here. So we just represent A in here. Good. Then we just solve this quadratic equation. So let's factorize this. So we want a number, a factor. If we add, we get what? 2 factor. If we add, we get negative 3. By multiply, we get what? 2. And that is negative 1, negative 2. Yes. So then we solve for, just bring bracket here, bracket here, bracket here, bracket here. Then factorize. Okay. So bracket here, bracket here, bracket here, bracket here. So I just factorize the A out. Then I have a out, then a times a is a square times a is a. So I have 2 here, 2 here. So I'll factor the 2 out. Negative 2 times a, I'll get the same thing. Negative 2 times negative will be positive. Or you can use the calculator to solve all this. Yes, and this is what we have. Therefore, our A is this. So those who use the calculator, you just get your answer as this. I also use your calculator. That's mode equation, then 3. Then you solve for this. As I just go back, then reach here. Very easy. So now you are just solving for S, not A, but A equals 3S. Now our A was 1 or 2. So let's start from 1, 2. So here I can solve for this, right? Because under indices said any number raised to the power 0 is 1. So it means that there's 3 here. So it's not 3 to the power 0 is 1. So our S is 0 here. Then the next one is 2. Then here 2, it will be difficult for us to solve for the S. That's why we have to apply the logarithm here. Okay. So we don't know any number that raised the power whatever. We don't know. It's difficult, very difficult. So you have to take log on both sides. So just take log on both sides. Then this the power will the S will come here. If the S come here, then we solve for what? S. We solve for S. Very easy. Very easy. Then you simplify. And this is your answer under these equations. Equation involving logarithm. Equation involving logarithm. Solve the following equation. So you are going to solve this equation, and this equation is being involving logarithm. Very nice equation. So you are going to apply all the rules under the logarithm to solve this kind of equation very easily. Okay, that equation involves logarithm. So from here, log 3s minus 1 to the base 10 plus log 4 to the base 10. This is a bit familiar. We can apply the product rule, maybe y. Okay, so it's like log a log s the base this one plus this log y to the same base a. Okay, here the same base a. So you apply this law here. Good. So there's 10 here, there's 10 here, there's the plus. So mean that we just maintain the log 10. Then this 4 will multiply this, the 3 here. Very good. So that things will be very nice. Very nice. So this can be written as using the power rule under logarithm. Using the power rule under logarithm. Very nice, very interesting. Now, there's log here, there's log here. So we just take anti-log. So this log will go and this log will go. Okay. Okay, that's the equality of law under the rule. I did talk about that one too. When we are summarizing it under equality of law, under equality of log. So this log 10, this log 10 will go. So we just have this grid. Then from here we can solve it. We can solve it. Very simple. You multiply through. So you just solve for S. Then you divide both sides by 3. Then our S is what? 2. Double that by 3. Our S is 2. 6 upon 3. Very interesting. And with these two, log 5, log 6s plus 5 to the base 5 minus log 6 to the base 5. And this one can be solved. So this one we just use the quotient law. That one was saying that log maybe a, then s divided by y can be written as log a s minus log a y. Do you remember this quotient property? Very easy. So just apply this. So the meaning that we just maintain the log, and this one is like our s. Okay, the first one. So just maintain the log, and then we divide by what? The 6, since it is what? Negative here. Okay, minus here. Very good. So just maintain the log. Let's maintain this. So this is what I'm trying to say. Yes. Okay. Yes. Very easy. So you can solve for this. So this is, can use the quotient rule under the logarithm. I did explain all this. So please revise those things. Now from here, you can use the definition of log to simplify this. Okay. So this log 5. The 5 will push this. Go and carry this. Using the definition of log, let's go and carry this. Okay. So go and carry the 2. Then so that the log will go. Good. Now it is on indices form. You can solve for this very easily. You can solve for this very easily. So 5 to the power 2 is 25. Then I just do cross multiplication. 6 times the 25. Yeah, you can solve for this. Then 6 times 5 is 1 is 150. We are solving for s. Double side by 6. Therefore, our answer is this. That's our answer under the equation involving logarithm. Yeah, so equation involving logarithm. So you should solve for the following equation. Yeah. So from here, the same idea. This one we can use the power rule and the logarithm because there's addition here, and the base are the log of the base are the same. So just maintain log to the base 5, then just multiply this and this using the power rule equals 1. And from here we use the definition of log. This 5 go and carry this one. That's if you push me, then I push you. Okay, so this 5 go and carry this very easily. That's the definition of logarithm. So from here we can simplify for this. Good. And this s times s is s squared. Then s times 6s, negative 2 times this. So this is what we are saying, s times s squared. Then s times is negative 6s, negative 2 times s is negative 2s, negative 2 times negative 6. That's what we get. Then we simplify further. Then we solve for the quadratic equation using your calculator. You solve for the quadratic equation. Then s. So here I just use my calculator. I don't know, don't go and find any factors here. So I just go to equation mode 5, then 3, then I just press 1 equals neg 8 equals neg 7 plus 7. That's 7 equals, then equals again, then s is 1, s is 7. So this the one will come here. Very simple. You just solve your quadratic equation. Now solving for this equation, you have to test them. Okay, you have to test them because we have two answers here, so you have to test whether the so when s is 1, so just have to put it in there. When s is 1, so log of this is impossible for this to solve this, so the answer is not 1, so 1 is wrong. So when s is 7, just have to put it in there. So 7 minus 2 is 5, then 5 log 1. So you have to test them. Yeah, so that's the answer. So it means that the 7, s is 1, so therefore our s is 7. Okay, so the 7 is correct, so you have to test for them. That's very easy. Our s is 7. Good. That's for um, equation involving logarithm. Very interesting topic. Please, whilst you are learning, please just write something down. Okay. Indices and logarithm. Equation involving logarithm. Solve the simultaneous equation. Wow. So now you're going to solve for simultaneous equation. I'll just pick this one first. Yeah, this one, just use the power rule for the log. And remember, I said that log, when the base is not given, it's in base 10, right? So log and log is here. So these two just multiply using the power rule. Good. Now, I have to get rid of this log. So these two will come here. Then become log upper sign. Okay. So I want to get rid of power. So this can be written as this. That's the log upper sign. That's the power rule. Okay. And this one is the product rule, and this one is the power rule, using the power rule. Okay, so this log will go and this log will go, then we have this. Therefore we can solve for this equation. That's equation 1. Then the next one with this, how should we solve for this? Yes, what should you do? What should you do for this? Yes, you can use the definition of logarithm. Good. Here is base 10. I'm saying that if you're not given a base, it's in base 10. Do you remember under the definition of logarithm? So here is base 10. Okay, so this base 10, we're going to push this way and go and carry this. Good, so that the log will go. That's the definition of what? Logarithm. Definition of logarithm. So please don't think a lot. Okay, good. So therefore we can simplify this. Number to the power 0 is 1. Then this become what? Equation 2. Then solve this 2 equation simultaneously. So you can either use the substitution method or elimination. It's up to you. And yes, using the substitution, multiply equation 2. I'll multiply equation 2 by 2. Okay, so that I'll have this. Yeah. So now this is my new equation for equation 2. Then I'll subtract equation 1 from equation 2. So this will go. So equation 1 from equation 3 rather. Yeah, I'll have this. Very good. This is what I'm going to do. Yeah, then subtract it from this. So this will go. I'm using elimination method. Okay, this will go. Then this subtraction, I'll get this. Very good. So therefore I can solve for this y, and it's a quadratic solution. Can find your factors and go and solve for this. Maybe I'm going for the calculator. So mode 5, then 3, then that's the quadratic equation. So 1 equals next 6 equals 8, then equals again, get s equals 2, s equals 4. Yeah, so if s equals 2, then mean I can write this as y minus 2, then y minus 4, and that's my answer for this. So when y was 2, we can solve for the s, okay, from equation 2. When y was 2, just do the substitution, make s the subject. This is what we get. S is 4. And when y was 4, the same thing, can solve for the s. And that's our answer for the s. Very good. And this is the equation involving logarithm and the simultaneous equation. Equation involving chain of base. So you are going to use the chain of base rule. So at least I have to quote the two of them here. Yes, chain of base is very tricky, but don't worry, it will be a bit easier for you. Without using calculator, find the value of the following. Find the value of the following, and we have this. Good. Yeah, asking how to solve for this kind of what equation. You have to solve for this kind of equation. And with the chain of base, we have to solve for this. Okay. So log of 8 to the base half, and then log divided by log of this to the base 1/4. So I'll just find this, take this, and solve for this. Yes. So log of 8 to the base half. I'm just solving for only this. So I'll just choose the base, my own base. I'm solving for only this. Later I'll come and solve for this. Okay. I'm solving for only this. Okay. That's all. B, log of bs. Then I just choose any base. I choose 2. Okay. Log 2 to the base 8. And log 2 to the base 1 on 2. This is what is here. Okay, the s, the 8 on top, and the b down here. Yeah. Okay, good. So divided by this, and this one the same thing. So I just choose 2 for all of them, because 2 can go, all of this 2 can go into 2 can go into 32. That's why I choose 2. Please don't go use 3. It will be difficult for you. So choose a base that you can divide. Okay, very good. So 2. So this thing I'm using this one. So log 32 to the base 2, then log 1/4 to the base 2. So just choose a base that will satisfy you. That will make your work a little bit easier. So that will make your work a little bit easier. Good. So this can be written as this. So I just choose the base. Yeah, that's for chain of base. And I can this 8, there's 2 here, so 2 to the power 3. Yes. And this can be written as, I can break this one down, can be written as this, divided by this one to there's 2 here, so also can be written as this. Yeah, it's like, so it's like 4 minus 1, and this can be written as 2 to the power 2 minus 1. Okay, that's what we are doing here. Very easy. Good. Now from here you can do a lot of simplification here, and this is the power rule, that log have a sign. So this 3 must come here, this negative one must come here. So like 93. So that everything is 93 here. Divided by, and this one to the 5 will come. And it's even go, it will go, because this and this are the same. So this will cancel this, or this cancel this will cancel that, this cancel that. And it's even identity, this one is 1 1 1 1. So anyhow we do it, it will go. So I'll have this divided by 5. Now it's a bit easier. That's our answer for this expression. Very easy, under the chain of base. 2. The log s to the base 2 plus 4 log 2 to the base s equals 5. And you see that there's s here. So this one too is chain of base. Here the base is s, so the chain of base. So we have to use this one to make things easier. So if here is b, I want to change this. So I want to change the s here. They become what? 1 out of s to the base 2. Okay. So this is what I'm trying to say. So we are just changing this one to this, from this definition, from this, from this. Okay. So because of this, can use this chain of base to do that. That things become easier. Then let's simplify this, the 4 times the 1. Then from here, I can multiply both sides by, um, or I can multiply both sides by this log, and I get this one log square. But let's make A represent log s to the base 2. So A is equal to log a to the base 2. So that simplification becomes a bit easier for me. So let's multiply both sides by A. Okay, so here by A, and here 2 by A, and here 2 by A. So this A will cancel this A. That's why it's number A. So you have A square plus 4. A square plus 4. That's A square plus 4. A square plus 4 equals 5A. Okay, when you multiply both sides by A here by A, here by A, here by A, this is what we have. And this one is even a quadratic form. Let's make use of our calculator, or you find the factors. So when you use your calculator and you solve it, you have A equals this and B equals this. Solve it yourself. Solve it, you find the factors and you start solving. Please solve it for yourself. But we are finding for S. Okay, so A is 1. Good. So log to the power S is 1. So here I can use the definition of log. So these two go and carry the 1. That's the definition for log. These two will just go and carry the 1. Then come S equals 2 to the power 1. That's the definition of log. And then 4, the same thing. Log S to the base 2. Then these two go and carry the 4. Then our S is this. So that's for the chain of base under logarithm. Subscribe to my videos for my YouTube channel, or you can DM me for more explanation. Bye bye. Application on exponential relation. Application on exponential relation. When A and B are constant, whilst S and Y are the variable, that's the independent and the dependent respectively. Okay, so A and B are the constant and S and Y are the variable. We have this. Another application of what? On the exponential relation, you have to know all this, but we are going to plot a certain graph. So now, this can be written as, let's take log of both sides. Okay, log of both sides. So after taking log of both sides, I can simplify this, and this one is even log as. This can break down. Okay, we can expand the log. And then we are saying that yes, log to the base 10 or base 10 when the log is not given, it's to the base 10. Okay, so log as can use the product rule. So it's like log a plus log s to the power n. That's the product rule for expansion here. Good. And this one is being the power rule. So this log about sign. So the b have to come here because there's 10 here. So let's rewrite this. Yes. Now we are just going to, this is the b. Let me rearrange this one nicely like this. I want it in this form. The same thing, but let's arrange this. Now I want to compare this with the equation of a line. That's the intercept y, the gradient. So from here, the log y is my y, okay, and the b is my m, and the m here is what? The gradient. That's the equation of the line. Then m here is the gradient. That's the equation of a line. And our s is the log s, and our c, that's the constant, is the log a. Okay, so when you have such explanation, when you have such work, this is how you go about this. Very good. We have another one here too. So the same thing here, I'll take log of both sides. Then I'll use the power rule. Yeah, the product rule. Yes, very easy. That's the product rule. and there's a power here, then I'll apply the power rule, the s will come here. Good. So now let me rearrange this one through nicely. What is s here? Okay, so that it will look like the gradient and the equation of a line. Okay, that's why I normally rearrange it. So my y is this, and this is normally for letting math people, and my m is s here. That's my s. Okay, anyway, see here, that's s, and this one is my m. My m is log what? B. Okay, very good. My m log b. So anyway, see s, just give s, anyway, see log y, you just give y. So now my m here is log b, not the s. My m is log b, not the s, and my intercept is the log a. So you see the difference here. So please, when you are solving, be careful. At first, the s was here. Now the s was at the power. So if the s comes here, don't say that the s here is your gradient because there's already s here. So you are just comparing. Very good. So I have this 2. Yeah. So this one, there's no need for me to go and take log of both sides. But no, this one is already on uh, equation form. So I can just simplify. So from here, my y will be, there's y here, y squared. And my m and my s will be what? Yes, my m is what? The a, and my s is s, and my c is b. So all this we are doing will help us to plot our graph, okay, when we are going to solve for application under the logarithm. So we have to know all this so we're able to plot it. So when you have this such question, you have to what? Expand this, then you compare, then you know how to what? To work it when we are dealing with what? The application on logarithm, okay? The application of logarithm on exponential relation. So I have a nice question here. The data below fits an equation of the form y equals b s to the power m. And this is what the data. Draw a suitable graph and use it to find the value of p and m, and hence y if s equals 6. So solution. This is a nice graph for us to solve. And this is what it's giving. Yes. So you see, so this one become a little bit difficult for us to plot the graph. Okay, so you have to make it in an equation of a line form. Okay, good. So you take log of both sides as we were doing earlier. Then I apply the product rule. Yes. Then the m is here, so I have to bring the m here. That's the power rule. That's called logarithm sign. That's the power rule. Good. So from here, let's make it nice. Okay, I want this one to come here. So the same thing, let's make it nice. Then I'll compare. And the way we are comparing. So now our y is log y, our m is m, our s is log s, and our c is log what? B. So therefore, we can plot this graph here nicely. So our s is log s, good, and our y is log y, good. So we just pick one. Our s here was 1. So log 1, as yes, well, log 1 is 0, 0. Okay, so log 2, so log 1 is 0, 0, because you know that log of the log 1 to the base of a number is 0, but since decimal, that's why I'm making it what? 0, 0, 0. So to 4 decimal place. Okay, log 1 is 0, so to 4 decimal place. Log 2, because s is 2 here, so log 2, good. Then move on to s is 3 here, so log 3 is what we get. S is 4 here, so log 4. Then s is 5 here, so log 5. Good. So let's move on to the y. The y is 2 here, so log 2. Y is 8 here, so log 8. y is 18 years, so log 18. Y is 33 years, so log 32. Y is 51 years, so log 51. Very good. So we are going to use this to plot what? A graph. Okay, we are going to use this to plot our graph. Very easy. So we are going to use our table to plot our graph, and this is my graph. So take your graph book and let's start plotting. So I just draw my line, then my x and y axis. Then I choose a scale. You choose a scale for yourself, depending on my numbers. So my x axis and my y axis. Good. So my y axis is 2, 3, 8, 0.1, 1.2, 1.4, 1.6, and 1.8. And then for the x axis, I'll just use 0.1 unit on 2 centimeter. Yes, 0.6, 0.7, 0.8. Then this is what we are going to use, and this was our table that we did. So we are going to plot all this. So s was 0.00, so my s was 0.00, my y was 0.3. So locate on the y as 0.3 is here. Good. Then s was 0.3, then my y was 0.9, so 0.3 to 0.9 is something here. Good. Then my s was 0.4, so 0.4, my y was 1.2, 1.2 is something here. Nice, perfect. Then my s was 0.6 to 1.5, 1.5 was something here. Perfect. Then my s was 0.699, approximately 0.7, so 0.7. Then my y was 1.7, so something here. Very good. Then I'll draw a straight line that best fits. Good. So then I'll find a gradient. This was the question. Find the value of b and m, and hence find y if s is 6. So to find the value of b and m, I have to find the m first. The m is the gradient. And what's the form of find the gradient? Yes. Good. y2 minus y1 is the form of find the gradient. So I'll just choose my gradient here. So I'll just choose this line. So I choose these two lines. So my y, that's it. I choose this. My y was 1.5, and my y, that's my y2. My one was this. I choose this for the gradient. So the y2 was 1.5, and our s was this. This is what I choose for the gradient. Therefore, my m is 2. Okay, good. Now I know m. I can find for the b, but we know that the c here is log b, so c is equal to what? Log b. Okay, as we are comparing, y is equal to this log, y is equal to log y, m is m, then s, then c is what? This. Very easy. Good. So from here, I'll just point this. Then I want to find the c, that's log b. So you should find the b. So from here, I'll choose any point I want. So I'll choose the first one. So I'll choose this one. Y is 0.3. Then my s will be 0. So 0.3 times 2.0. Yeah, I just choose this one, the first one. Okay, to do it. After solving, w is equal to 0.3. Then I'll use the definition of log. So here is base 10. The log is base 10. So the 10 will push this and go and carry what? The 0.3. Very good. That's the definition of log. You all know. Therefore, my b is this. Very good. So now I know my m and b. So from here, Since I know the m and the b, okay, my b, so the equation my b is this, and my m is 2. Very true. And they say we should find y if s is 6. So s is 6 here. Just do the substitution in here. So 6 squared, 36, so 1.136, we can find this. You just do the substitution in here. Therefore, your y is very easy, very easy, very easy, very easy. Subscribe to my YouTube channel for more videos. And if you need one-on-one online, just DM me. You can just send me hi on the comments, or I have a link. You can just click on the link and join my WhatsApp platform. Good. For more explanation. So subscribe to Sneapolus, my YouTube channel, for more videos. Yes. And if you want one-on-one or online, one-on-one with me, you just go to the comment section. You can send me hi there under my YouTube channel, or I have a link. You just click on the link. It will send to my WhatsApp page. Then we can have one-on-one teaching or face-to-face. Very good. Mathematics is very easy, and this logarithm is very easy. Don't shake with logarithm and the mathematics. Bye bye.